and welcome to another episode of the Energy Central Power Perspectives podcast. As our regular listeners know, this is the show where we bring in utility leaders to discuss the state of the industry and look forward to the continued evolution taking place across the energy sector. We bring in leading minds in the energy and utility industry and challenge them on their work, their thinking, and what to look for in the coming years. The term resilience is often used to describe anyone or anything that can bounce back from a major setback. With mounting pressure weighing on our utilities, resilience is the appropriate term to describe the strength of our energy system. And Matt, what have you seen recently from the Energy Central community about resilience?
Yeah, Jason, it's an area our community definitely cares a lot about. And honestly, through the posts and the conversations on Energy Central, I see some anxiety and some urgency. So definitely time to get this work into overdrive.
Yeah, absolutely. Well, today's episode is going to take us directly to the ground in the tropical U.S. Virgin Islands, USVI, where the constant threat of hurricanes and the challenges of importing fuel are fairly ubiquitous across the entire region of the Caribbean. But the solutions have been coming too slowly. Our guest today was directly involved in a compelling project that brought together grid modernization, extreme weather resilience, and equitable access to energy. So we're really excited to learn more from him firsthand. But before we bring him into the booth to talk about lessons learned in energy development in the hard-hit Caribbean, we'd like to give a word of thanks to the sponsors of this podcast who made this episode possible. To West Monroe. West Monroe works with the nation's largest electric, gas, and water utilities in their telecommunication, grid modernization, and digital and workforce transformations. West Monroe brings a multidisciplinary team that blends utility operations and technology expertise to address modernizing aging infrastructure, advisory on transportation electrification, ADMS deployments, and DER and cybersecurity. To ESRI. ESRI is an international supplier of geographic information, GIS software, web GIS, and geodatabase management applications. To Guidehouse, formerly Navigant Research, a premier market research and advisory firm covering the global energy transformation. To Anterix. Anterix is focused on delivering transformative broadband that enables the modernization of critical infrastructure for the energy, transportation, logistics, and other sectors of our economy. And to Scott Madden, a management consulting firm serving clients across the energy utility ecosystem. Areas of focus include transmission and distribution, the grid edge, generation, energy markets, rates and regulation, corporate sustainability, and corporate services. The firm helps clients develop and implement strategies, improve critical operations, reorganize departments and entire companies, and implement myriad initiatives. Our guest today is Tom McGeehan, VP at E-Finity Distributed Generation. As we've seen too often, such as with Hurricane Maria in Puerto Rico, or more recently, the entire 2021 hurricane season in the Caribbean, centralized grids are easily brought down, putting entire communities at risk. Is the centralized distribution system for the region outdated? Are we kidding ourselves given climate change, and are we expecting too much from the island utilities? As we rely more on a traditional, centralized system, we're putting more people at risk. Do we need to redefine resiliency in this part of the world? Without power to keep medical equipment running, food and medicine refrigerated, the worst can happen. But there are options, and many of us are looking to transform what the grids on these island nations look like. Tom McGeehan is here to talk about this and how his company, E-Finity, is addressing these questions. Tom has spent nearly a decade with E-Finity, having brought with him experience on power generation technology, energy efficiency measures, and other critical factors that define the grid. Tom's team recently completed a project in the U.S. Virgin Islands, and when we heard about it, we knew we had to have him on the show to share with our listeners. And I'm sure many of you listening to the podcast today can relate to his story. So with that said, let's bring him into the podcast booth and hear straight from him. Tom McGeehan, welcome to the Energy Central Power Perspectives podcast.
Thank you, Jason and Matt, for having me on today. I'm really excited to talk about some of the cool projects that we have going on in the Caribbean and where we're deploying some decentralized microgrids.
Thanks, Tom. We're thrilled to have you as well. Tom, take us to the project you developed in the USVI and level set for us with the existing conditions of the electric grid and the economic situation on the island.
Sure, Jason. And for any of your listeners that are not familiar with the U.S. Virgin Island, it's comprised of three major islands, the St. Thomas, St. Croix, and St. John. The local utility company there is called WAPA, and they mostly generate power from a mix of propane and diesel fuel with a little bit of renewables mixed in. The islands tend to be very hilly, so the terrain tends to be pretty rough, and the entire distribution and transmission system is above ground, and that leaves it susceptible to storms and outages. The grid tends to be unreliable, with daily outages fairly commonplace. Electric prices are also high. They tend to be anywhere from 40 to 45 cents a kilowatt hour, which is, depending on where you are in the US, anywhere from 2 to 10 times higher. In addition, the USVI also suffers from a housing shortage. Land is very expensive, and it's difficult to find affordable housing. In 2017, the island was hit with the Cat 5 Hurricane Irma with peak 178 mile an hour winds. And that really wiped out a lot of the local housing that they have on the island. So the three main problems that we see in the Virgin Islands right now is one, an unreliable utility grid, two, very high electric prices, and three, an affordable housing problem.
So then, to address the challenges, you worked on a microgrid solution that directly benefited local USVI households. Tell us about that.
Sure, that's correct. A few years ago, we were approached by a development company called Jackson Development, and they were partnering with the USVI Housing Authority to develop affordable housing projects in St. Thomas. So basically, the government was offering tax incentives for private development to come in and build affordable housing on the island. And these affordable housing complexes are unlike traditional projects that you would see in the Virgin Islands. The apartments tend to have amenities like pools, community centers, air conditioning, which is really not common in a lot of the Caribbean countries. The developer turned to us. They were looking to have a more reliable form of electricity for their project. And they also wanted to offer the tenants more affordable power. So they didn't want them to be paying 40 to 45 cents per kilowatt hour. So they turned to E-Finity to come up with a solution for their energy plan to design a utility grid that is independent of the local utility. We worked with our partner, Hitachi Energy, to design a microgrid that incorporates 455 kW of capstone microturbines, 150 kW of solar PV, 450 kW of diesel generator, and a 1 megawatt battery energy storage system that was supplied by Hitachi Energy. This microgrid is totally independent of the local utility grid. We also capture the exhaust heat off of the microturbines to make 100% of the building's hot water in a combined heat and power application. This microgrid is really efficient with all the technologies that we're using. Today, the complex consists of two towers that have 108 units and is being powered 100% by the microgrid system. The system is hurricane hardened and designed to run through another storm like Irma. It's also a win-win for the tenants because they don't have to worry about losing power on a weekly basis. And they're also able to buy power for less than what the local utility would be charging them.
Tom, can you speak a bit more about the energy storage systems that play into this story? How do the battery systems assist in extreme weather events?
So the battery storage system is designed to supply end users with power directly from the actual battery storage system. And our controls define when the batteries get charged. And that's typically the batteries getting charged with the solar PV during the daytime, and the batteries in conjunction are providing power to the buildings. When the sun goes down at night and the solar shuts off, the microturbines will turn on and charge the battery energy storage system and continue to provide power to the tenants. Even in the events during the day when the solar PV and the battery are running, if they're, for some reason, it could be a cloudy day or it could be very hot and a lot of the air conditioners are running, well, the microturbines will also turn on to help capture those peaks. But when you really think about it, the battery energy storage system is the heart of the entire project. So if you think of it as a body, your arms and legs would be your distributed generation assets that are working. So that's could be your solar PV, your diesel generator, your microturbine, a wind turbine if it's in a project. Everything flows through that heart, which is the battery energy storage system. And that's really where all the power comes from it. So when you think about it too, it's almost very similar to the utility being the transmission and distribution system. Everything goes through the battery system, whether it's being charged or being used directly by the customer.
Great. Well, it sounds like a great project, and it sounds like the customers are benefiting immensely. But let's take the utilities perspective, because that's our audience here. How are the utilities viewing this project, and how are the utilities maybe taking advantage, or what was the experience like working with the utilities through all this?
So this project is actually decentralized from the local utility. So they didn't have any involvement in it. And when you think of traditional power generation in the US and in the Caribbean, you have central power plants, and then the power is transmitted through the transmission and distribution system. In the US, we're starting to see a switch over to utilities really starting to embrace microgrids. You're seeing the Southern Company in the Southeast, on the West Coast in California, there's a lot of utility scale microgrids. We're starting to also see some smaller scale microgrids in the US, in California and in the East Coast. But in the Caribbean, where utilities could really benefit from this is doing smaller, decentralized microgrids. So let's say, for example, you have a resort that wants to build on your island, but the resort looks and they say, wow, well, the electric rates are pretty high here. We've looked, the utilities unreliable, all the poles and wires are above ground. It's just better for us to build our own on-site microgrid and power generation where we could generate power for less than the utility and have it on site where it's more reliable and not susceptible to storm. Where utilities can take advantages, instead of losing that customer and losing that revenue, they can start embracing the small scale microgrids. And they could come in, say to that resort, hey, you know what? We understand that you don't want to be on the grid and you're thinking about building your own microgrid. Well, what we could do differently is we're going to come in and we're going to build, own, and operate that microgrid for you, finance it, and sell you the power back under a power purchase agreement. And the benefit to the utility is they're keeping that customer.
Yeah, but Tom, isn't the utility the provider of last resort, and don't you have an interconnection that has to be addressed?
That's a good question. So the project that we did in the Virgin Islands, they decided not to connect to the utility. The utility could not provide them 480 volt, which is what they needed. And they also did not want to connect because of the unreliable of the utility. So the microgrids that I'm talking about, Jason, are decentralized microgrids. So not connected to the actual utility grid, but connected directly at the end use client. So the end use client is the one benefiting from the microgrid.
It sounds like a physical solution that fits nicely with what's needed here, but these systems also create an enormous amount of data, right? Performance data, quality of energy, health data, usage data, demand data, and so on. So can you talk about that? What is the data story behind it? And are you collecting the data and measuring it?
Yeah, it's a great question. So there's a lot of data that goes into a project like this, especially when it's new construction. You have to start off by just building an energy profile. And in the Caribbean, you have a lot of seasonality to that load profile. So not just the daily changes, but the seasonality changes of when you have a lot of tourists coming in and you're going to have higher demand at certain times of year. So what we actually start off doing is we use ASHRAE models to kind of scale out and get a load profile of what the building's electric load is going to look like during the day and also throughout the year. Once we're able to come up with that profile, then what we do is we have pretty sophisticated modeling software that we'll load it into, and it'll start then to calculate what kind of microgrid generation assets we need. And depending on the customer's needs will dictate what the microgrid looks like, what the renewable fraction could be. But some customers might come to us and say, hey, I want to have 50% renewables in my microgrid, and the rest could be clean burning fossil fuel, like a propane or an LNG. And we'll put that in and we'll model it, and it'll come out and it'll say, hey, this is what the microgrid should look like in terms of generation assets. We could also run the models based on economics. So some clients care about net present value and ROI, and that'll dictate, again, what kind of power generation assets are in the microgrid. Once the microgrid is up and running, data again plays a key role. We're monitoring these 24/7, 365. Like I had mentioned earlier, there is no utility for last resort. The microgrid is it, basically the utility for the customer. So it's critical that these assets run 24/7, 365. We have predictive software that tells us to when we think the sun's going to come up, and we're constantly monitoring to make sure that the battery state of charge is at a certain level to make sure that we're going to be able to keep the site up and running at all times.
Well, that's great. Basically, given the decentralized model, you've created like the ideal A/B test, those who are on the microgrid and those who are not. What differences are you seeing? And do you have, because we're talking about resilience here, are you talking about capturing and comparing performance data, outage data, Acadian safety, performance metrics? What are you seeing in these A/B tests, or have you even started them?
That's a great question. So we're constantly testing and monitoring and tracking any kind of data on any outages that we have. The microgrid that I spoke about earlier in St. Thomas, it's been up and running for a little over, I would say, about a year and a half. There's only been one outage with the microgrid, and fortunately it was for a few hours. It wasn't even our end, it was something that the contractor on site did to take it out. We also have another site in St. Thomas where we have more data. That's been running for 4 years, and that has only had one outage. That is a high-end resort on the island. Another site where it's not connected to the grid. They have their own microgrid to provide power to the site. In terms of comparing that to the local utility, we don't have that data of how many outages they have. From the data that we have on the local utility on the island, they have had far more outages than our sites have had. Each time we have had an outage on the two sites that I spoke about, it was a lesson learned, and we mitigated that problem so it would never happen again. So we're constantly shooting to have 100% uptime. You can imagine if you're at a high-end resort, you're going to want to have power 24/7.
I mean, this is a region, right? That's climate change is only going to, impact the grid even further. So let's put siting issues and cost aside. Is this just the start of rethinking about power for the region? What do you see as some of the answers or solutions for the Caribbean, given the conditions that are going on there?
The rest of the Caribbean faces the same risks that St. Thomas has. A lot of these islands rely on fossil fuels, so that's either diesel. A lot of them, though, are converting to cleaner burning fuels like propane and LNG. These fuels still need to be shipped in, though, so it tends to be expensive and has a higher environmental impact. So power costs tend to be fairly high. And a lot of these grids tend to be older and the lines are above ground. And as everyone knows, the Caribbean is susceptible to hurricanes. So we're seeing a huge push for more decentralized microgrids. A lot of the utilities are stepping up and putting in, even in St. Thomas, the utility has a lot of projects planned to do smaller scale microgrids throughout the island to reinforce certain areas. So as the future goes on, we're going to see more and more microgrid projects throughout the Caribbean islands. And I think you're going to see them directly at their end use customers. So benefiting affordable housing in the Virgin Islands or resorts in the Turks and Caicos. I think this is what the future holds, is with small scale microgrids in these islands.
Yeah, I would agree. I mean, I think it's probably a combination of things, putting more lines underground, microgrids, other grid edge solutions. It's a region that needs answers because the challenges they're facing are certainly not going away. And what about those battery storage systems? Are they going to play a bigger role in the U.S. Virgin Islands than in other grid systems across the globe?
Globally, the demand for battery energy storage systems is huge right now, especially in the U.S. We're seeing a lot of projects on the utility scale, but also smaller systems now starting to go on. These are projects where the battery is directly on site and where it's being used. So in the U.S., we're starting to see this in places like California, where electric rates are higher and they're susceptible to grid outages from fires. Also now on the East Coast, seeing demand in mid-Atlantic states, which are also prone to severe weather events like Hurricane Sandy, where over 8 million customers lost power. And in the Caribbean, which faces hurricane threats, but also very expensive power, we're seeing more and more projects incorporate battery energy storage systems. I really think the battery market is going to grow exponentially over the next decade, similar to what we saw with the natural gas market this past decade. On the smaller scale side too, we've really enjoyed working with a partner like Hitachi Energy because their battery solutions are scalable. They have small solutions from 50 kW all the way up to the 1 megawatt range. And this has been helpful for us where we're working on smaller projects, which could be small apartment complex, but then to very large projects like a 400 or 500 key resort where we would need multiple megawatt hours of storage systems. It's been good working with them. Their product line really fits what our customers are demanding.
Time for the lightning round, Tom. We'd like to shift this to our listeners to let them get to know you a bit more on a personal level. So your responses will just be one word or phrase. Are you ready?
Yes, I am ready.
Okay. You have to pick one meal for the rest of your life. What do you choose?
This is a tough one, but I'm going to have to go with something that's healthy. So let's go with chicken.
What's the best time of the year, in your opinion?
Being from the Northeast, 100% the fall.
Did you pick up any hobbies or interests over the pandemic period?
Yes, having children. I had 2.
What would be your superhero power?
After this conversation, I'd have to say Captain Planet.
And what are you most optimistic about?
A cleaner utility grid.
Terrific. Tom, now we want to give you the last word today. So how can our utility leaders who are listening in today's episode from the U.S. and across North America and even globally apply the lessons you learned in this project? What's the takeaway?
First off, Jason and Matt, I would like to thank you for having me on today to speak about some of the work that we're doing in the USVI and Caribbean. I really think it's an exciting time to be part of the power industry, and we're really going to see major transformations over the next decade as we help fight global warming. I think some of the lessons learned that utility leaders can take away from our projects are, first off, you don't always have to think about larger scale utility scale. Smaller microgrids work, and they could really benefit the utility. Instead of losing customers that are decoupling from the grid, the utilities could come in, own and operate these microgrids and not lose that revenue from the customer and continue to serve them and provide them with a reliable, clean, on-site power solution. The second would be for the off-grid microgrids. It's critical to size the system correctly because really there is no backup. So for some reason, your microgrid goes down, you really can't call on the utility to help you because the microgrid is the supplier or the delivery of last resort. And third off, account for where your project is located. So if it's in a place like the Caribbean, make sure that all the equipment that you're getting is hurricane rated. A lot of these projects will get them hurricane rated up to category 5 because that's what we've seen recently in the Caribbean with storms like Irma and Maria over the past few years that have really devastated a lot of the islands. So with that said, again, I thank you for having me on today. I enjoyed the conversation.
Likewise, so we're thrilled to have you on, and thank you for taking time for us and our listeners. So we hope you and the listeners keep the conversation going in the comments section of the post with this podcast episode. Thank you again for joining us today.
Thank you.
You can always reach Tom through the Energy Central platform where he welcomes your questions and comments. Once again, I'm your host, Jason Price. Plug in and stay fully charged in the discussion by hopping into the community at energycentral.com. And we'll see you next time at the Energy Central Power Perspectives Podcast.